Hello once again, everybody, and welcome back. We're looking at question number 19 in this video on our 2016 Fermat. There are N students in the math club at Scoynes Secondary School. When Mrs. Fryer tries to put the N students in groups of 4, there is one group with fewer than 4 students, but all of the other groups are complete. When she tries to put the N students in groups of 3, there are 3 more complete groups than there were with groups of 4, and there is again exactly one group that is not complete. So it would have either 1 or 2 people in it. When she tries to put the N students in groups of 2, there are 5 more complete groups than there were when she split them into groups of 3, and there is again exactly one group that is not complete. So if it's a group, it's got to have at least one person in it, but it's not complete, so it can't have 2 people in it, so it's got to have one person in it. And we just want to figure out the sum of the digits of the integer that's equal to n squared minus n. Now, I think this question was on all 3 papers this year, Pascal, Cayley, and Fermat. Okay, I will have done other videos about this one, but I genuinely can't remember exactly the right approach that I used in the other videos, or I might have used a couple approaches. But I really want to focus on this sort of group of 2 because I know this is basically just a question where they're giving me knowledge of remainders and such. And I know that if I take n and I divide it into, say, so many groups, let's say g groups of 2, then n is 2 times g plus a remainder of 1. Okay? Now, if we take a look at the groups of 3, there were, well, if I have g groups of 2, there are 5 more groups of 2 than there are groups of 3, so there will be g minus 5, and then plus some remainder. And I don't know what that remainder is. It's got to be 1 or 2, because we're told there's one group that's left over. And we can also say n is 4 times, there were 3 less groups of 4 than there are groups of 3, so g minus 8, plus some other remainder, which we know even less about. It'll have to be 1, 2, or 3. Now we can ignore 2 right away because, well, n here is seen to easily be odd. And if I had 4 times something plus 2, n wouldn't be odd, so that would be a contradiction. And we need to figure out n squared minus n. Well, the sum of the digits of that, I think we'll probably have to figure out what n is. Okay. So, number these equations here. So I like the first one. It tells me n is odd, which is fantastic. What else can we do? I'm going to expand out 2. Let's see, 3g minus 15 plus r. Now, I know that that's equal to n, but so is 2g plus 1. And so if I subtract 2g from both sides, and I add 15 to both sides, I'll get g plus r is 16. Well, that doesn't exactly help me figure out what r is, but it does sort of, I guess it gives me some possibilities. R could be 1, and then g would be 15. Or r could be 2, and that would imply that g is 14. I guess we could try these and see what happens. Now, I don't think that there's not really much point in plugging it into equation 1 or equation 2, because they're the ones that helped us understand this relationship. But, well, let's plug, let's say g equals 15 and r equals 1. Let's plug that into equation 1, so n is 2 times 15 plus 1. That's going to be 31. So now if I plug in g is equal to 15 into our third equation, I'll get 4 g minus 8 plus some remainder. I'm worried about this s here. But let's do 4, 15 minus 8 plus s, and that would be 4 times 7, 28 plus s. I guess for these two to be true, s has to be 3. But that's allowable. You're allowed to have s is equal to 3, so maybe n is 31? let's try the other case. So g being equal to 14, so the remainder r being equal to 2. Plug that into the first equation, you'll get n is 29. If I plug g equals 14 into the third equation, I'll get 4 times 14 minus 8 plus s. 14 minus 8 is 6. 6 times 4, 24 plus s. For these two to both be happy, s has to be equal to 5. Well, no, because then we'd have an extra complete group, and we were told there were... Actually, we weren't told how many complete groups. I went back to the wrong thing. We were told that you had g minus 8, or 8 less than when you split them into 2, and then you have one incomplete group. S could only be 1 or 3. So S can't be 5. So that means this case is impossible, and so S is 3 and n is 31. And so n is 31. If I do 31 squared minus 31, and feel free to grab a calculator if you need to, you'll get 930, and the sum of the digits 9 plus 3 plus 0 is 12. So 12 is going to be our answer, and that's B. So for question number 19, we bubble in B. We got one more question to go in this part B, and that'll be question number 20, and we will handle that next time.